All right, you guys. So yesterday we started talking about explicit and recursive formulas, how we can create them for arithmetic sequences, and use them for application problems. So we're talking about linear recursion. A couple questions that we should have been able to do after what we did yesterday. First one, we should be able to identify an explicit formula of the following arithmetic sequence. So I give you an arithmetic sequence, and I'm asking you to create an explicit formula. So first off, let's just go over what the explicit formula is going to look like. We'll have a sub n equals a sub 1 plus d times n minus 1. And we're going to come back to that here in just a second because we're going to find those elements that need to go in for your a sub 1 and your d. If we remember correctly, your a sub 1 is your first term. So if I'm looking at this sequence, I know that my a sub 1 is my first term, and that's a 3. After that, we also can find our d value. That's what we need to plug in right here. So our d value is going to be our common difference. It's what we're going up by, or what we're adding to get from our first term to our second term, and so forth. So in this case, to get from 3 to 9, I add 6. To get from 9 to 15, I add 6. To get from 15 to 21, I add 6. So we know it's arithmetic because we're adding the same thing as we go up each term, and it's a common difference that we call it. We label it d, and we can go ahead and write that over here, that our d is 6. In order to be able to finish the explicit formula, we have the basic explicit formula. We're going to plug in our 3 for our a sub 1. We're going to plug in our 6 for our d. We're going to distribute, and then we're going to simplify. So in this case, our a sub 1 was 3. I'm going to plug that in. Our d was 6. I'm going to plug that in. And then I'm going to write the rest of it. Okay, so now at this step, we can go ahead and distribute this 6 into our parentheses. Didn't do anything with the 3, so we're going to bring that down. When we distribute, we get plus 6n, and then minus 6. And now we need to combine our like terms. So we have a like term right here and right here. When we combine those, we end up getting 6n minus 3. So this is going to be the explicit formula of that sequence. Explicit formulas are very useful if you want to find the 100th term. We can plug in 100 for our n because that's the term we're looking for, and that can quickly get us the 100th term instead of continuing to do a pattern. Now, if we want to continue to do a pattern, that's more so about a recursive formula, and that's what we're looking at in the next question. We want to be able to convert the following explicit formula to a recursive formula. There was 2 things that we needed for a recursive formula. The first thing that we needed is we had to know the first term. So that's going to be a blank that we need to fill in. The second thing that we needed is we needed the common difference. If you recall, our recursive formula looks like a sub n is equal to a sub n minus 1 plus the common difference. And so in this case, as long as we can identify the first term and we can identify the d, we can use this formula as a recursive formula. So I'm going to go ahead and do that. In order to find the first term, I'm going to use this explicit formula just like I said we could have used this one. I'm looking for the first term, so a sub 1 is what I'm looking for. And I'm going to plug a 1 in for that n value. When I do the multiplication, 2 times 1 is 2, and then 2 minus 1 is 1. So our first term is 1. In order to find the common difference, I'm going to go ahead and find the second term as well. Since I already know that it's an explicit formula of an arithmetic sequence, if I find the first term and the second term, I should be able to simply see what's different, what it's going up by, what it's going down by to find the difference. So then in this case, a sub 2 is going to be equal to 2 times 2 minus 1. We can do our multiplication and get 4 minus 1, and then 4 minus 1 gives us 3. So our next term is 3. So in order to find the difference, if I start at 1 and I'm going up to 3, I'm going up by 2. So my d value, which I'm going to write just down here, is 2. So now that I know that my first term is 1, which is necessary in order to be able to use a recursive formula, we have to identify the first term. And I know that my d value is 2. I can simply plug in my d value and we're finished. So a sub n equals a sub n minus 1 plus 2, because that's our d value. So a recursive formula has those two elements. The formula itself, which we've just written out by finding our d value, and then you have to identify the first term in order for us to be able to use it. So yesterday we talked about how to be able to identify if something's an arithmetic sequence or not, how to identify a d or a common difference, how to identify a first term, how to be able to create an explicit formula, how to use an explicit formula, how to be able to create a recursive formula, similar to what we did over here, how to be able to convert from one formula to the other formula. And today we're going to focus on, or the next thing we'll focus on, is putting that through application problems.